Okay, so now we are on activity 4, and what we have is a beaker of hydrochloric acid. This is a strong acid, as we know, which means that these hydrogen ions will have completely dissociated from the chlorine ions, and I'm sure we'll look at a molecular view to see what's happening there. But what we're going to do is put these different metals into the solution and see if a reaction occurs. We're waiting for the reaction to occur. Okay, we can remove it. Doesn't look like much happened there. If we looked at a molecular scale reaction, there are your hydrogen ions. We're ignoring the chlorine ions and the water molecules. And our solid silver metal looks pretty intact here. There's not an exchange of electrons happening. So that silver, you can put it into hydrochloric acid, does not appear as though a reaction has occurred. Okay, let's try copper next, see if a reaction happens when we put it in our hydrochloric acid. Remove it. Doesn't look like a reaction has occurred. I don't think I need to show you the molecular view on that one. Let's try nickel. Oh, look, a reaction is happening. We see bubbles of gas coming out of our solution. There seems to have been a reaction between the nickel and the hydrogen ions. Okay. Ooh, looks like we lost a little bit of nickel here. Okay, where did it go? Let's look at our molecular scale reaction. The hydrogen ions are exchanging electrons with the nickel, and then the hydrogen pairs up and forms a gas, and that ends up leaving the beaker. And where did our nickel go? It seemed that our nickel bar shrunk a little bit at the bottom. Well, that's because some of those nickel ions are now in solution. Okay, and if I go step by step, notice in this reaction that the electrons are transferred directly from a nickel atom to two hydrogen ions, and that should say +1. That's a typo right there. The chemical change that occurs can be represented by the following. Here's your molecular equation, and here's your net ionic equation with the spectator chlorine ions removed. This is an oxidation reduction reaction. Two H+ ions collide at the surface of the nickel electrode. A nickel atom releases 2 electrons to the H2+ ion. There they say that again. The nickel atom enters, each nickel is reacting with 2 hydrogens. I'm not sure where this is coming from. That seems to be a mistake. Okay, but this is oxidation. A neutral nickel atom loses 2 electrons and forms an Ni2+ ion. The oxidation state of nickel changes from 0 to 2+. There's been a gain in oxidation state, but a loss of electrons. Each H+ from the hydrochloric acid solution captures 1 electron. These 2 atoms form a hydrogen molecule. Okay, so again, that was a typo before because you have 2 ions. Each one is gaining an electron, and then they pair up to form hydrogen gas. Okay, and that's reduction. All right, there you go. All right, let's go back. If we put our lead into our solution, we see a reaction again. Those are hydrogen H2 bubbles being released. The lead bar seems to have shrunk a little bit. And now let's do tin. We see a reaction again. Now we're going to be able to put this into our reactivity series as well, where hydrogen fits in to our series of reactivity. All right, so there are your results. And now we can add hydrogen gas and hydrogen ions into our spectrum of reactivity.